Welcome back to exercise 1E. We'll learn all about inequalities now, and this is not a sob story regards politics or anything like that. This is a mathematical inequalities, so you can relax. Today I hope you will be very clear on how to write inequalities from number lines and be able to solve linear inequalities. The examples are 12 and 14. Excuse me, that should be example 12, not example 13. And for your pre-learning, I hope I haven't made it too much of a mess with writing the alls and halves. Do half of question 5 and 6 and all of 4 and 7, okay? Question 4 is super easy or super quick, and you want to think about all those examples, and there's not a lot to question 7. Okay, so here's the key ideas. We've got the 4 inequality signs, okay? So as you can see them at the top there, we've got a strictly less than, or a less than or equal to, greater than, strictly greater than, or a greater than or equal to, okay? And we mark them on the number line. So for example, x is greater than a. So this is all the x's that are greater than a. Here's a on the number line. But strictly greater than means we draw a little clear circle here because we mean x's that are strictly greater than. So that does not include a. But of course it includes every number up to it. So you could have a 0.00000000000001, and that is greater than a. And when we're talking about greater than or equals to, well, of course, that includes a. So in the next example, we've got a solid circle there, okay? And the arrow indicates off to infinity, okay? So both of them are greater than or equal to. So that's all the numbers that are great. There's a lot of numbers, trust me. And same goes for the negatives, okay? So for the less than signs, we're pointing off towards negative infinity. This one here, so where you have, I'm highlighting where I'm looking at. So you got this a, and then this it's a is less than x, so that means that x is less than a, and x is also less than, a is less than x. That means that x is greater than a, and x is less than or equal to b. So we're looking at all the x's in this range. Okay, so this is strictly greater than a, and less than or equal to b. So this number line finishes, there's no arrow, okay? No arrow, does not go off to infinity, it is strictly in that band. It should be, hopefully it's pretty clear with those pictures where we use the strictly greater than or equal to. Okay, so the other thing to remember is, and I have written down pretty much everything that I've just said there, okay? So the strictly greater than does not include a, so that's the circle is saying we're not including it. We'll be doing the linear inequalities in this one. So it's exactly the same as backtracking or whatever you want to call it with solving linear equations, except, big yellow except, when we multiply or divide by a negative number, and hopefully you know dividing by now is multiplying by a negative inverse, so that's why it's pretty much the same thing. We flip the sign, okay, and you'll see that in the examples, and I'll explain a little bit more with the examples. And the other thing is when we flip reciprocals, we also flip the sign, okay? So a less than becomes a greater than, or a greater than or equal to becomes a less than or equal to, or whatever. So that's when we involve negatives or flipping reciprocals, okay? And see example 14b. Okay, once again, you got your videos here. We're asked to write these things as inequalities, okay? So the first one is a whole, like an empty circle there. So it is a strictly greater than. And I know, so the x's are what I'm worried about. This is the red arrow indicates the x's, and it goes off to infinity. That's what that arrow means. So it is x is greater than 2, and that's it, okay? Strictly greater than, not including, so not equal to. And for the next one, for part B, so all the numbers there are both 1. You can see an open circle for 0, so x is, well, you can see a closed circle above -3, so x is definitely greater than -3, or -3, another way of saying that, or -3 is less than or equal to x, okay? And x is less than, strictly less than 0, okay? So, and the reason why I did this little or thing is, right, because we're going to write them together. So -3 is less than or equal to x, and x is less than 0. So we're bounding x on both up and below and above it, okay? So that looks terrible the way I wrote that. So -3 is less than or equal to x, and because x is greater than it. All right, so this is how you write them together, and that's exactly what that part B question is indicating, that sort of number line. Why have I got the keyboard coming up like this? That's annoying. Okay, now example 14 is solving the linear equalities. So I've used the blue here to indicate the backtracking that I'm doing. So we've got the 3x plus 4 is greater than 13, right? So I'm just just adding negative numbers here, or subtracting, so nothing changes, the sign stays the same. And then I divide by 3 because I'm getting rid of the 3 next to the x, and so that's a positive number, so nothing changes. So that ends up being x is greater than 3, okay? So any x where 3x plus 4 is greater than 13 is basically the same as saying any x greater than 3, okay? And to draw that on the number line, x is strictly greater, I'm going to use a red line to follow the fashion of the, okay, so strictly greater than, and it's off to infinity. Away we go, whee! All right, and next one, part B. So we've got a negative sign here, so you can see things are going to be complicated, but 4 minus x divided by 3 is going to be less than or equal to 6. So I subtract 4 from both sides and multiply both sides by 3, so it gets rid of the fraction bit. So now I've got minus x is less than -6. So what does that mean to say minus x is less than 6? So minus 7, right, is, well, minus 7 is not less than -6, is it? Because it will be greater than, so we've got to think about this -6 here now. We've got a strictly we've got a greater than or equal to 6, okay? So think about it. Minus 7 is positive 7. That's not less than 6. Minus 8, that's positive 8. That is not less than 6. And minus 5 is minus 5, so it's positive 5. That is less than 6. And you can put it back into the initial expression as well. Okay, so what's happened here is, I should put a note there, I have flipped sign, or flipped inequality when multiplying by -1. Okay, and so this one here, We've done nothing of the sort, okay? So I was quite careful to choose, so for example, if I had gone the other way, let me do it this way. So if I had minus 6x from both sides, I'd end up with minus 3x. And if I add 2 to both sides, I've got minus 3x is greater than 2 plus 2 is minus 2, and x divided by minus 3, and then if I flip it around, becomes x less than, I made a mistake there, have I? That should have been minus 6 to start with. So minus 6 divided by minus 3 becomes 2, and it still ends up being the same thing, okay? So I'm going to have x strictly less than 2. So open circle, and away it goes, off to infinity, okay? The only other thing which I'm going to add here is a little added bonus, is the thing I was talking to you about, reciprocals, okay? So reciprocals. So if I said to you that if 1 divided by x is going to be less than 1, another way of saying that is 1 divided by x is going to be less than 1 divided by 1. And then I flip them over, and that means so that x is greater than 1. Okay, and now you think about that, 2 is greater than 1, and 1/2 is less than 1, and so on and so forth. Okay, so this is another thing to look out for, but I'm not sure how much you're going to cover it in this exercise. Just looking at that, they seem to leave that alone there. But yeah, there's some quite difficult mixed inequalities in the enrichment part. So I do challenge you to get up to that part. If you complete your pre-learning at home, you will have time for that in class, okay? So don't forget that the negatives flip the sign. Otherwise, it's like a normal inequality, and you draw this off to infinity, or in the case of this one, we've got 2 signs working on this one, haven't we? We've got minus 3 is less than or equal to x, which is less than 0. All right, so please get that pre-learning done, get into class, ready to go, and to push ourselves to the limit. All right, see you there.